The key to industry transformation, the key to success is
AI, 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 AI.
Let's talk about AI. Right. If you're here, you're probably already sold on the whole AI thing. Maybe you're like me and you're a web developer wanting to get in the field, but you keep running across derivative functions and calculus, and then your eyes glaze over and you go back to learning the latest and greatest JavaScript thing 2.0. Or maybe, just maybe, you're worried about the robots taking over, and you want to get on their good side before it's too late. I don't blame you. AI is a pretty broad field, so we're mostly talking about generative AI and machine learning. But for the sake of the algorithm, let's throw a few more AIs in there just to be sure. AI, 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 AI. So why is everyone on the AI hype train anyway? You may be familiar with the broad strokes, but let's go ahead and recap. Generative AI, I think, is pretty obvious. It allows you to create things from simple prompts. Machine learning, on the other hand, doesn't quite get the same spotlight, but it's foundational to everything else. Let's take the sentence, how many scholarly articles do I have about cats? Now imagine trying to create an algorithm using traditional coding to parse that. Not so easy, right? Well, that's fuzzy logic and natural language processing for you. Then there's feature extraction. That kind of looks like a thumb, right? We also have pattern recognition. Maybe whenever I open my laptop, I also start the coffee maker. We have adaptability. Whenever I open my laptop, go ahead and start that coffee maker for me. And lastly, prediction. Whenever I'm staying up late, I'm probably going to want a lot of extra coffee. What if I told you this whole intro was artificially generated? It wasn't. That'd be pretty cool, right? Don't worry, we'll get there. But today, let's start small. Let's code a local only, open source only, no API keys, no cloud services, LLM chat app. Don't worry, the really cool stuff is coming, but first we gotta start small. Cover the basics. Before we get to the code though, we got some fundamentals to cover. Some context, you might say. Shall this be our context window perhaps? All right, let's talk about how LLMs work. Well, first, let's actually talk about how Markov chains work. We'll get back to LLMs in a second. So, a Markov chain is just a model that describes a sequence of events where the probability of each event depends only on the previous event. Easy peasy, right? Not quite? I think it'll make sense in just a minute. Now, if you know a thing or two about LLMs and Markov chains, you might be worried that I'm about to say that LLMs are basically Markov chains. Don't worry, I'm not. LLMs are basically Markov chains. Sort of. To be clear, saying an LLM is a larger, fancier Markov chain is sort of like saying a cargo plane is a larger, fancier carrier pigeon. Sort of true, superficially, but not really. In actuality, LLMs are more complex than that. For now though, let's use Markov chains as kind of like an entry point to understanding how things work, just so we can get started. We'll go over the proper explanation later. With that in mind, let's go over how LLMs kinda, sort of work. You give an LLM an input, and then it will continually generate the next probable token until it hits a stopping point or until it hits the context window limit. For LLMs, tokens are just the base unit that an LLM works with. In most cases, that's a word, but it can vary between models. In the context window, it's just the max number of tokens an LLM can operate on at a given time. keep in mind that token window limit includes your initial input too, since the LLM continually generates the next token based on all the previous ones. All right, let's go over an example. Let's say we use the prompt, "I want to eat a," and then the model generates the following possible tokens. Burger is the most probable, sorry cabbage, so that gets selected. The model then generates the next token using all the previous ones, and later is selected. So this continues until the stopping point is the most probable choice. But you may have noticed something here. Anything stand out? If we're always using the top token choice, then shouldn't we always get the same result? And wouldn't that be kind of boring? Well, for one thing, we're dealing with probabilities. Also, LLMs have a temperature parameter. The temperature parameter controls how often lower ranked tokens are used. Lower temperature means safe and predictable, and a higher temperature means random and potentially spicy. To put this in perspective, your workplace chatbot should probably use a lower temperature, while your creative writing helper can go off the rails. Models like Llama are just a bunch of parameters. They're not actually a runtime, and you can find all kinds of them on Hugging Face, which is sort of like the GitHub for ML models. But as we said, you need something to be able to actually run them. We're going to use a tool called Ollama. That's right, Ollama, to run our language models. This process is also referred to as inference. Ollama, like many other tools, is just a wrapper around Llama C++. But it comes with a bunch of handy conveniences like a web server, clients, GPU support, and a library of ready-to-go models. In short, it makes getting started very easy. Now, to be fair, if you just want to get up and running with these models quickly, there are existing tools out there like LM Studio and OpenWebUI. But what's the fun of that? We're going to build it from scratch so we can better understand things. Let's go ahead and dive in. So I'm going to assume you have a web development skill set. It's not strictly required. I mean, if you're an architect, please by all means keep watching, but it's going to be a lot easier if you do. On the back end, we're going to be using Python because everything these days is written in Python. And on the front end, we're going to be using JavaScript, obviously. If you're familiar with UI component libraries like Svelte or React, that's going to be a plus. We're also going to be using Docker to package things up, make it easier to run, and we're going to be working in the command line. Let's go ahead and set up our project. So we're going to start really simple and iterate on it. For this first pass, let's just do server side, post to the server, get the response back. Classic web development. So let's go ahead and make dir, cd into this dir. Then we'll set up all of our other terminal windows. I've got a few tabs here just so that we can stream the console output in the foreground. So we'll use this one for Docker. Later on, this will be JavaScript, and this one's just a free one to run some commands. Let's go ahead and create some files. So to get started, let's go ahead and let's open our project in VS Code. Doesn't have to be VS Code. That's just the one I'm using. Nice and modular. All right, we're gonna get some dot files over here. We're gonna do editor config, git ignore, and .env. Let's go ahead and git init as well so we can see the diffs. So editor config, nothing really special here, just some formatting stuff. Git ignore, nothing really special here. Ignore VS Code, environment, and Docker volumes, as well as some Python stuff. And let's go ahead. We'll take a look at .env in a second. Let's do our Docker compose file. And let's take a look here. So we've got only 2 services right now. We've only got a Python app, Python container. I'm going to actually increment this. I've been doing a lot of prototyping here, and I don't want Docker to complain. So the first service is our web container. And again, this is just going to be our Python app. Pretty standard stuff. We're going to build from our app directory. We are going to actually use Docker to inject the environment variables from our environment file here. So this saves us from having to use a Python package to do it. So Docker is actually going to inject that in there for us. Otherwise, we'd have to use a Python package. We've got some port mappings here. The only thing special to note is just that on Mac OS, 5000 is reserved for AirPlay. So we're just going to use 5001 and map that to 5000. So on our host, we're going to be accessing it with 5001. We've got some volumes here. So the first one's pretty standard. This is going to be for our actual source code. The rest of these are for caching pip packages. And there's a little bit of a gotcha here that we'll go over in a second, but basically it allows us to not have to reinstall everything every time we're spinning up the container. And then taking a look at some other environment variables, we just have a debug flag here. We have the debugger pin. So this is in our Flask app. We'll take a look at that in a second, but it makes it easier on local to just hard code that. And actually, I should mention, this is not production ready, so you shouldn't be running just the built-in web server. You shouldn't be exposing the ports outside the host. You know, you'd normally have it behind Nginx or something like that, and you'd be locking down the ports such that only the host machine can get to it, not actually anything. So, okay, so debugger pin. Then we've also got the Ollama instance. So you'll see here we've got an Ollama Docker container. I'm right now running an Intel Mac, modest boy over here. So whether we're running it natively or whether we're running it in the container, there's really not much performance difference. It's not great. So that's why I'm just running a container here, just for simplicity's sake. Technically, if you do have a GPU or if you have, like an M chip, you probably would see some benefit running it on the host. So running Ollama not in a container, but rather on your host machine. And then in that case, you would map it like this. So you would use that special Docker host name to be able to hit the host Ollama instance. Also, finer details there. If you're running on Linux, there's ways to expose your GPU to the container. Maybe we'll deal with that later. But for now, simple Intel Mac performance for inference is not great. So we're just going to keep it simple and use a container. And that actually ties into the model. So we're going to be using Tiny Dolphin. Tiny Llama is another one. These are 1 billion parameter model files. So they're small, they're lightweight, they have decent performance for CPU in terms of the number of tokens it's able to generate. The quality of responses isn't great. Credit where due, it's a very small model. I think Tiny Dolphin does a little better than Tiny Llama. So we'll be using that, and it's really good for just getting started as a proof of concept and just checking that things are working as expected. Down the road, we'll use proper hardware, and we'll be able to use a proper model like Llama 3. And that does it for our Python container, and actually pretty much the Ollama container. The only thing we've got there is just some port mappings. These are the default. And then also the volumes. This is where we're going to store our model files, our model weights. And actually, believe it or not, the other attempt at doing this, my Mac bricked itself when I was trying to pull the model file. Well, I think I bricked my machine. That's fun. I don't know what happened there. That's unfortunate. So we're actually going to cheat just a little bit and copy over the volumes for Ollama and not have that on the fly, because this is third time's the charm. So let's go ahead and do that. So I'm just populating the volumes directory. I'll get rid of the app one so we can kind of see how that will work. But at least for Ollama, we've got our model weights here. So let's get into it. All right, so we've got our container, Docker Compose spec. That's all, again, pretty simple for now. We're just trying to get up and running off the ground. So let's start working on our app directory. So this is where our Python app is gonna live. If we take a look at our app directory, we're gonna have a few things in here, starting with some top level stuff. Let's pull over our requirements, our app, our config, Docker file, that kind of stuff. And we'll go through it one at a time. So the Docker file, we'll start with that. Pretty simple. We're just using the Python image, official image, and we're using the slim variant because we really don't need all the extra packages. The Alpine one could work too. In development, I was having some issues with getting some of these packages to work correctly, so I just stuck with slim. We're setting the working directory in the container. No big deal there. We're going to copy over our requirements file, run pip install, copy the rest of the source code, and then we're going to run our entry point. As we had talked about previously, the volumes for the Python packages are mapped. So that's good because once it's installed, it's there. But the gotcha here is the very first time you set up the container, the volume mount is going to overwrite the base image. So pip is going to be wiped out because it'll be an empty directory. So we're going to actually use an entry file, and you'll actually need to make this executable. This is going to be tracked already because I copied it over. So make sure this is executable chmod x. So what it's doing here is just checking if pip's there, and if it's not, then go ahead and reinstall pip, and then reinstall our requirements, and then continue to do whatever it was supposed to do. So you can see here, in our case, that would be Python appy, which is just going to start up the built-in web server. And that's it for the Docker file. Really simple. Let's take a look at our requirements, and then we'll dive into the actual app code. For now, it's just Flask and just Ollama. Key distinction here is that this is the Ollama Python package. It's not the Ollama runtime or anything like that. So this is just an Ollama client that kind of provides some helper methods. It wraps the HTTP calls, and it's just a little bit nicer to work with. All right, getting there. Config, pretty simple. It's just an object class, I should say, that provides some config properties. So we've got just an app name that's going to be used in our templates, whatever port we're running on, debug. If it's one of true, one, or T, then it'll get set to true, otherwise set it to false. And this is just handling the environment variables getting read as a string. So it's going to check for these strings. If it's one of those, it sets it as a Boolean. If not, it's Boolean false. Then we have our Ollama instance and whatever model, the name of the model we're running. Alrighty, let's take a look at app. So this is a pretty simple Flask app for right now. There's nothing too fancy in here. The only things that may stand out are just our config object and this LLM client that we're gonna code up in a second. So in terms of the shape of what we got going on here, we've got our, this is where we're actually instantiating the app, and we're just gonna use kind of like a creation function that then we're gonna do some bootstrap stuff in the sense of we're booting up the app, not in the framework, although we are gonna use Bootstrap CSS. So we're creating our app, we're setting our config from that config class, and then we're going to run this app boot function, which is just going to actually do some initial setup where it puts the LLM client, which is our helper, in the Flask context. So this pattern, it's kind of like a singleton, and it's should be thread safe. So you can just call get LLM client. If it's not already set, it creates it, and otherwise it returns it. And again, this should be thread safe. All right, so we're just doing that little bit of bootstrapping. We've got a 404 handler, pretty standard stuff there. If we're not in debug, we're gonna have an error handler. The reason why this is only added, or the reason why I have it added just for non-debug, is so that if we are in debug, we can throw or raise an exception, and then that gets us to Flask's built-in pseudo step debugger. That's just kind of handy for quickly stepping through things, inspecting variables, that kind of stuff. All right, so index and index post. So index is just going to render the index template, pretty standard stuff, nothing too fancy there. And then index post is going to listen for the post method. And really what it's doing is taking this form data, sending it off to the LLM and getting the response back. And that's it. Those are our routes. Those are our controllers. And we are nearly there. So let's go ahead and take a look at that LLM client. So we'll go ahead and populate that. And actually, while we're at it, we'll go ahead and populate the rest of the directories so we can breeze through those and get to running this. All right, so services, LLM client, very simple, right? So we've just got a class, kind of like a helper class. When we create it, an instance of it, we're just passing in Ollama instance URL, the model name, and then we're creating the client. So keep in mind, this is the Ollama Python client, and it's just gonna provide those helpers. And then we're saving it so that we can access it later. And it really only has one method that we'll be working with, which is just given an input, get the models, language models output. For now, because we're doing a first pass, simple request response, classic web dev, we're just going to wait for the model to generate the full response and then return that once it's complete. In a second, or down the road, later on, we'll use JavaScript and we'll do streams so that we're getting the response as it's being generated. So we're not waiting for the entire response, we're kind of sending it off to the end user while it's being created, and that provides a little bit nicer user experience. And then this clean output is just a helper that trims out any of the underlying LLM tokens. Okay, really close. Static is just going to have some CSS stuff. In this case, it's app CSS, which only has one thing in there just for placeholder's sake and just to make sure it's all wired up. Bootstrap is standard Bootstrap. And then we've got some templates. 404, error, and page are all going to be pretty much the same thing. Taking a look at layout first, this is what all the other templates are going to extend. So again, pretty standard stuff. We are just laying out the page, having some sections that we can populate, and that's pretty much it. So 404, error, and page. So this would be our 404 controller. Error, likewise. Nothing too fancy there. And page is just kind of like our default catch-all. Index, on the other hand, is a little different in that we are adding an HTML form that we'll then post off to, and then that's how we interact with the LLM. Okay. And with that, we should be good to go. So keep in mind, there would be some setup steps you'd need to take. So for one, you would chmod that entry point, and then I'll go ahead and start the stack. So this is in my shell history. You don't actually have to stop it if it's not already stopped. Doesn't hurt. You would actually just be doing up and build. So this is going to spin up our containers. It's going to pull those pip packages, and yep, so it's running through. We can see right here it said pip cannot be found, reinstalling, so that's to be expected. So it's gonna reprocess those. What you'd also have to do if this is your first time is you'd actually have to pull the model file. So in this case, again, I copied over a cached copy of the model weights. But if it's your first time running it, you'll have to pull the model. So you could do it something like this, where it's docker execute name of container. Keep in mind we changed it to 3, but name of container, Olama run, and then model name, and that will both pull the model and then allow you to chat with it. So we're not going to do that. We're going to let the CPU have as much time as it needs and as much resources. So it'll reinstall the pip packages, and then once it's ready to go, we'll take a look. Okay, actually, I think we are good to go. So you can see here, debugger pin 123 debugger is active, and then in our app boot, we fire off a request in a thread to the LLM, and we can see we're getting some stuff back. All right, so we're keeping in mind we're on localhost 5001. Let's see what we got. All right, great. So what do we got going on here? We've got it tiny dolphin, we've got a form. Let's just say hi. So old school request response, we can see that the LLM came back with that. And let's keep this in the foreground actually, so we can kind of see some of the stuff going on here. You can see in my browser history, so we could say like, what is a CPU? And you can see that it's calling Olama, and it's got a response back. So first pass, things are looking pretty good, right? We have got the LLM running, we've got a basic, super basic chat app running, and we're able to interact with it. So hopefully you're kind of seeing the broad strokes come together, and we've got many more things we're going to be working on. So let's refine this a little bit. All right, let's go ahead and add some JavaScript and make this UX a little bit better. So I am going to stop the stack, and actually let's go ahead and commit so we can see some diffs. And init commit of LLM chat commit. Yes, we would like to stage everything, and then that. All right, so let's close our tabs to the right. Actually, we can close everything. All right, so we stop the stack. Our browser is done. All right, what do we need to do? So we are going to add in Svelte to this. So let's go ahead, and we're in our chat app, right? So cd app, and then we are going to create a directory called components. Make dir components. It's looking good. And then let's go ahead and do npm create Svelte. Well, create Vite, and we'll go from there. Project name is, let's call it chats. We'll do Svelte. We'll use TypeScript. We're not going to use SvelteKit for this because it's just one component. It's really simple. So we'll just work with standard TypeScript based. Okay. ls cd components, ls cd Got it. Okay, we need to remove that directory. Move to components. I think that. CD components, CD and CG chant. All right, now npm I, and let's take a look here. And we should have a just boilerplate Svelte app going. So if we do npm run dev, it's not going to be anything fancy. We're just making sure that we've at least got Svelte up and running. :5173. Okay, cool. So we've got a Svelte app running. That's good. Let's commit this so we can see some diffs, because we're going to need to redo some things. So let's go ahead and commit. Let's stage everything, and let's do init Svelte. We want to change this up a little bit to make it behave nicely with Flask. So that's what we're gonna do here. We're gonna need to change up some things. Okay, let's take a look and let's walk through what we're changing here. So in components, index. Okay, that is a little bit different. So we're gonna add a new command here to the package file. What we're going to do is call a new command build w. So this is build and watch, because we're going to want to interact with Flask. We're not going to go directly to Svelte and the JavaScript web server. We're going to need to mess with our Vite config a little bit here. So if we pull this up, let's see what we got here. All right, so what are we doing here? Vite config, you can see we changed how it's generating the output. So normally it would checksum or fingerprint the files. We're gonna go ahead and hard code the outputs here, and that's just so we can link it up to our Flask templates. All right, so we've also got a public dir. We don't need this logo here. So let's go ahead and get rid of that. Make sure we're getting that together. Let's see. Yeah, there's also an app CSS. We don't need any of that. So let's get that out of the way because it's going to inherit our app styles. Let's take a look at app.svelte. Yeah. So for now, we're taking out all of the boilerplate stuff and just making sure this actually runs. Okay, there's a svelte.svg. Yeah, let's get rid of that. Okay. We have a counter. We don't need that. So we have our app here. Let's go ahead and save it. And actually, let's go ahead and run npm run build w, and let's see if this works. So you can see here we're building the Svelte app to this this dist directory. So index we don't really care about. We do care index.html, index.js we do care about. This is what we're going to need for our Flask app. So we need to get the Flask static directory to look for our Svelte components. So let's go ahead and wire that up. So cd app static. We're going to make a directory in our static directory for components. Components, this is going to seem a little bit funky, but what we're going to do is create a symlink from here. So this is from here to the output of our Svelte component. So What we've done here now is we should be able to reference this from the static directory in our templates and in our layouts. So let's take a look at that, because we need to reference our Svelte stuff. Yeah, and you can see here our symlink is showing up. So now when we do this, we need to make sure we are doing this. Nope. So chat, and this is chat, and then we've also got one down here that is yeah, and we should be good. We're gonna add some styles later, so on second thought, let's put this back under comments. And now we should be good. All right, so what are we doing? We have wired up Svelte to build predictably named files, and then we've symlinked it so that it's in our static directory for Flask. And we are going to reference the component in our index. So this whole form, it's going away. Get it out of here. We're going to use Svelte for that. So yeah, so we're creating a div here with ID of app, and then because we're loading up our Svelte JavaScript, it's going to know to go ahead and replace that. And we can see that working in our Svelte main. So it's just looking for that app, and it's going to go ahead and replace it. And then that's where we then jump into here. So if I did everything correctly, we'll go ahead and start the stack again. We've got JavaScript running here, right? So as we're making changes to our Svelte app, it'll rebuild it. We've got our Flask Docker stack here. So keep in mind, Svelte isn't being served from a web server over here. We're just watching for changes and rebuilding it. The Docker Flask app is what we're actually working with here. We're running, and we should be back in here in just a second. Olama's up. Now if we go back here, we see it lives. Right, this is great. So we have our Svelte app within Flask, and from here we can go ahead and build on it, but let's go ahead and save our changes so we can see exactly what did to wire everything up and make it play nicely. So let's stage all those, and we'll move on to an actual chat, and we'll be nearly done. Set up Svelte to work with Flask, and that should be all we need to do. Okay. Still with me? Hanging in there? We're almost there, I promise. So let's close all and let's see what we got going on. Now that we've got JavaScript and we've got front-end component we can work with, we're going to change up the UX a little bit. So right now it's request response, traditional server. Instead, we're going to be using that Svelte app as our UI, and the Flask app is kind of going to act as almost our own internal API, REST API, HTTP API. So let's change up our app.py file just a little bit. So let's go ahead and do that and see what we've got here. Just a little bit different. The only thing we really should be changing here is just the response from the prompt. Previously, we were doing a post to the index, and that was just going to do a server render. Now what we're doing is we are going to send an AJAX request. We're going to add a new endpoint called prompt. It accepts a post, and functionally it's the same thing, right? We're sending a prompt and we're going to get a JSON response back out. And that should be it. for our app.py. Now we're going to need to do quite a bit for our Svelte app to get it up and running. So let's dive into that. All right, so we're going to need to set up quite a few components here. Let's dive into source, app.svelte. It's going to be quite a bit, but we'll run through it. And actually this will probably error out because it's saying there's not any of these modules here. So let's fill those in while we're at it too. And then we'll explain everything we just did. So we're going to want a chat form. We're going to want a chat message. We're going to want a loading spinner, just kind of a good UX. We're going to want a notification. That'll come later. And then finally, we're just going to have some helper methods, so utils. All right, let's just go ahead and populate these real quick so that the build runs successfully, and we'll dive into each of them. So chat form, chat message, loading dots, and toast. And one more, some basic utils. Okay. And with that, we should be good to go. Yeah. And let's just make sure. Okay, cool. All right, so let's take a look at what we actually did here. So our app.svelte looks a lot different now. We've got a import from the utils where we're going to be making an HTTP request, and we're also going to be throttling because we don't want to be sending a bunch of requests needlessly. We're going to want to make it so that we're only sending requests when we're, done typing, for example. We've got a chat form that's going to be this thing right here. That's going to take our messages, our prompts, I should say, and we've got chat messages. We'll show that in a second. We've got a toast. That's just going to be an error handler. Like if the server's down, we'll have a little notification pop up and stuff like that. This abort controller is a HTTP or JavaScript class that we can use so that if we are stacking up AJAX requests, we can cancel them when the next one comes in. So we're throttling, but let's just say hypothetically, we're doing a request per keystroke. We can have it so that, we're not sending requests and waiting for them. The next time a request comes in, cancel the previous one. We've also got some just kind of standard objects here. This is going to be the shape of our chat messages. We'll get into it in a second, but basically body, author, and timestamp, and then the notification message, pretty similar. So title, body, and what the state is, which is kind of like a visual indicator. So we're just doing a structured clone here so that we can reset it. So we'll call reset, and then it'll clone it again. This is done so that we don't copy by reference, because by default JavaScript is by reference. So if we were to just do toast message equals default toast message, when we're setting like toast message .title, well, now our default's getting messed up too. So that's what the structured clone is, and this is baked in to JavaScript and more recent specs. We've got some state toggles here, like is loading, show toast. This is just gonna, helper variables we can use to toggle UI stuff. Current prompt is just for our chat form, and messages is gonna be our array of messages. So that is our basic state, and then let's take a look at some of these event handlers. Not too many. So we're gonna handle the chat form submit, in our chat form, so we've got our chat form component. When this tells us that a chat message was submitted, or when the form was submitted, we're going to handle that up here. We're going to set it to loading, abort any other previous requests, push the current chat message on to our stack of messages. So this would be the current prompt. So if I say, I'll go ahead and do it. Like, what is a CPU? All right, so we haven't done anything yet. We're going to submit this form. And we can see here that it is, that it is not loading our CSS because we need to put that in there. Let's try that again. What is a CPU? There we go. We'll do that, and we can see now it's loading. It's going back to the server, and we get this response back. Yeah, so if we go back now that we're rendering things properly, we can see here we're just going to push our message onto the stack. That's this thing here. We're going to create a request body. We're then going to clear out the current prompt, because when we hit submit, we don't want it to just hang there. Right, so it gets cleared out. We're going to then make a request to the backend LLM, and then we'll get it back and kind of add it to the stack. No biggie, right? So refresh messages is just a way to trick Svelte to handle arrays reactively. And then it's also going to scroll to the bottom, which is just a, just a helper function here to kind of scroll to the latest message. Flash toast, hide toast, not too much there. We can throw an error intentionally, and that should get us to see that toast message. So now that we're throwing an error from our prompt, we get it back, and we can see there was a toast error here. So let's get that out of the way. Right, okay, so that is the overview of the main app Svelte file, right? So we're just handling that form submit, and we're sending it off to the server. And this do request and the throttle are pretty simple. Do request is really, it's just doing a fetch. And then throttle is just a, again, wrapping. Allows you to wrap a function in a throttle. So not much there. We're getting there, and let's take a look at the chat form. Pretty standard Svelte stuff, right? We're not really doing too much here. We're just binding the prompt, and we're gonna have an event handler, right? So when we hit that submit, we're gonna dispatch an event that we can then listen to in the parent, right? So that's gonna be here. So when we get this event, that's where we go back to that submit handler. And then for the messages, pretty standard stuff, right? We're just looping through them, and we're displaying them as a component. And yeah, there's not much here, right? Just some state and some formatting and some styling. Loading dots is a standard CSS loader, and toast is likewise just pretty standard, right? Some state, and with that, so we've got our basic JS chat app, right? And we can see we got our loading dots, and yeah, so our UX is getting there. It's a lot better than that old request response, right? Because we can add things to the stack. How are you? we're getting responses back, but there's still some other things we need to do here. So if I were to put in a prompt that would get back a lot of information, what is NVIDIA? We're going to see that there's an issue with how these messages come back. There is a lot of text here, and sometimes if you say, what are the steps to boiling eggs, the formatting doesn't quite come out super great, especially in longer text blocks. The LLM will attempt to do some type of plain text formatting where it does line breaks and stuff like that, but that's just not coming through, right? Because we're just getting plain text. So for our next step, let's go ahead and see if we can properly format these and get it so that it's coming out a little bit nicer. Yeah, so take a look at this. This should be a numbered list right here, and it's not. So to do that, we're just going to rely on a package called Showdown that is just going to be a markdown formatter. Technically, this isn't markdown per se, but it has enough overlap that it actually works out pretty well. So let's take a look at our package file, and let's add Showdown as a dependency. Let's stop with this. Let's do npmi, get this dependency in here, and now let's do run build. And all we're going to need to do, really simple change, we are just going to, in our chat message, so let's go back to our chat message component. Let's now import Showdown here. And let's create a Showdown converter. And then what we're going to do is we're going to have a reactive prop here that is based on the message body. And then we'll just reference that and we'll treat it as markup. So if we go down here, as the message body, message I should say, gets changed, we're just going to create a reactive variable that is just going to be whatever Showdown thinks should be the HTML version of it. And again, we're relying on the fact that Markdown and the text formatting that these LLMs spit out are pretty close and work pretty well. All right, so with that, let's go ahead and refresh our page and say, what are the steps to boil an egg? This is kind of slow, but we'll give it a minute and see now what comes out. And a little bit of a typo here, but that's the beauty of these things, is that they should be able to handle it. Okay, so that took a while. Dolphin is, it's working on it, but we can see here we now have some formatting. So we're almost there. We've just got one more thing to do, and that's going to be streaming, and we should be able to call it for this first part. Home stretch. We've just got one more thing to do, and that's to add some output streaming to make this UX a little bit nicer. You noticed that when we waited for a pretty long response, we had to wait for the entire time it was generating, and we can do better than that. So let's go ahead and do some output streaming. We're just going to need to change a few things. We're going to need to change our app.py. Let's go ahead and add a controller in here that will respond to streams. So we've got our prompt here. First, let's go ahead and commit. And this will be both the initial UI chat as well as the body formatting. All right, so let's take a look at our app.py. So we've got our standard prompt here. But again, this is going to just wait for the entirety of the response back. And that's not the right place to add it. Let's add it there. It's gonna freak out. And now we should be good. So we're gonna add another endpoint. It's also a post. It's prompt-stream. And what it's gonna do, it looks a lot like the first one we did. But you'll notice here that instead of getting JSON output, we're actually going to return an HTTP event stream. So this is those server sent events. And then we're just going to need to add a method to our LLM client to send out that stream. And then we'll update our Svelte app and we'll be done. So let's go ahead and update our LLM client. Pretty easy there as well. So likewise, we've got get LLM response. We're going to do get LLM response stream. These are different intentionally. They look very much the same. The only difference is stream true right here when we're calling Ollama. And then we're also doing a generator function. As we're getting these responses back, we're going to yield the output. And that's actually the reason why we have to do two different functions, because it's a generator. This one's a regular one, this one's a generator. You can't mix them. It doesn't work. I tried. But if you just do some sort of a flag here where it's like stream equals, whatever stream, it still blows up. So they're different functions. And that's all we need to do there. And then lastly, we just need to adjust our app.svelte slightly. Because now instead of getting just a JSON response back, we're going to get a HTTP stream, and it's going to look pretty much the same. We've just got a few changes here. So when we're getting our response back, this is what's changed. So before we were just getting a single JSON response back, and that was pretty easy, right? Here we are going to request prompt stream like before. We're going to check if the response is okay. And then what we're going to do is get an reader here that's going to be able to read that stream. And then while we're reading that stream, we're going to be able to get the responses back. So you can see here that reader allows us to know when we're done. So we're getting our chunks back, right? So we're getting the text from our reader, and then we're just adding it to the output. And the very first time, we are going to add the token and then set the date and then say that we loaded the first token. And then after that, as we're going through, we're just going to append the next token. And then we're formatting it. And that's pretty much it, right? So before we were just getting the entirety of the message and setting it as our message. Now we're getting a stream back token by token, and we're gonna add those tokens together. And then at the end, we'll have a complete message. So let's see here, we still have Docker and still have our build function. So if we do a response, let's just do a simple one just to make sure we didn't miss anything.
So now we should see, that may have been a little too quick, so let's try it again. let's say what is a CPU? And we should see tokens coming in bit by bit. Let's try, how do you boil an egg?
Prompt. I might need to do a hard refresh real quick. Let's just make sure we saved it. We did not save it. Silly me. All right, so now if we do this again and say hi, yeah, there we go. Now we're cooking. All right. So you could already see there we're getting token by token. So let's go, how do you boil an egg? And again, I put and, but it still figured it out. And you can see here, this is much better well, it's much better from a UX perspective. This gets back to the imprecise and unpredictable nature of these LLMs sometimes, and specifically with Tiny Dolphin. What steps do you take to boil an egg? I think is what we used before to get that bulleted list. And what we can see here is, right, super long response. Before we had to wait for a while to get these back, but now we're able to kind of see the response as it's coming out of the LLM, and this is such a better user experience. And yeah, it works pretty well. You know, we have a chat app that's totally serviceable. Mind you, we're just using the data that's baked into the LLM, so that's something we can improve on. For today, though, I think that's all I have for you. But next time, we're actually gonna make this LLM aware of our own stuff, our own data, with a little thing called RAG. So that's all. Thanks so much for watching, and we'll see you on the next one. Okay, and then let's also do... But for the sake of the recommendation algorithm, I'm going to throw a few more in. Imagine trying to create an algorithm using traditional coding to parse that. Not too easy, right? Well, that's fuzzy language and fuzzy... models? No.